Hello, I'm Jason with ScienceandMath.com. Today we're going to use materials that you can find around the house to demonstrate to you what air pressure really is and also how strong it is. And you can do it with materials that you can almost certainly find in just a few minutes. All you need for this experiment is a soda straw, any length will do, 2 cups, these could be paper or plastic cups, I recommend plastic to start, and you'll need a bucket of water, which we have here. Now you can also use the kitchen sink or even the bathtub. In fact, you can do this whole experiment while you're in the bathtub if you'd like. So what we want to do is take both of our cups that we have here and submerge them all the way down under the water. We want to basically completely fill both cups up with water. And that's why I say it's kind of nice if you can do this even in the bathtub if you'd like, since you're already in there anyway. So we're going to turn both cups lip to lip, basically. And you want to put them together after they're full of water. They both have to be completely full of water. That's why we have a lot of water here. And then what you're going to do is lift them quickly vertical, like this. Now at this point inside of this bucket, I have a cup full of water on the bottom, and I have a cup full of water on the top that's resting on top of it. Now to make it a little more impressive, what I'm going to do is carefully lift this guy out and place it in the empty container, just so we can see exactly what's going on here. Now the first part of this experiment's actually already done, because what you really have here, even though you can't see what's inside of these cups, what you have here is a cup full of water on the bottom and another cup full of water on the top. So the first question you should ask yourself is, how is that possible? How is it possible to have all of the weight of this water on the top that's basically not leaking out? We're watching it, none of it's really leaking out. How are we able to really do that? And the answer really is air pressure. What you have inside the cups, inside the cup you have water that's trying to get out. So we say it exerts pressure. It means it pushes on the seam all the way around. It's pushing, trying to get out. Also, you have air all around this cup, and even though you can't really feel it on your skin, the air pressure is pretty powerful, and it's actually pushing on the cup, and it's pushing on the seam back. So at this interface of the 2 cups, you have the inside water pressure trying to make the water come out, and you have the outside air pressure pushing, trying to keep the water in. And right now, everything's perfectly balanced so that all the water is basically staying inside of the cups here. Now let me make it a little more impressive for you, and just slide the top cup back just a little bit where I can just start to see an opening there. Now look carefully at what I have. If you look carefully there, you'll actually see that there's a separation now between the 2 lips of that cup. There's actually a gap there. You can actually see the water there. So again, what's happening is the water is trying to get out, but the air pressure, which is all around us because of the atmosphere of Earth, is sitting on top of you and it's pushing on you, and that air pressure is pushing and keeping that water inside. And so everything is totally balanced, inside and outside pressure. Now what we need to do to try to get this water out, I guess the way you could phrase this in terms of a joke or a bet is you could say, all right, I bet you that I can get this water completely out of the top of this cup without touching the cup, without grabbing it, without touching it, without doing anything to it regarding my hands. I can get the water out of this top cup. Most people will look at you a little funny and say you can't do it, but what you need is a straw. So what I'm going to do is place this straw right near the little gap that I created in there, and what I'm going to do is gently blow inside of there. And as I do that, I want you to pay special attention to the little gap that we have right here between the 2 cups. So what I'm going to do is place the straw about a few centimeters from it and gently, you don't blow too powerfully, you just gently blow in. Here we go. Now if you notice carefully, what's happening is you can hear the bubbling and the gurgling of the water. As I blow the air into the cup, the water is evacuated and comes out the other side and goes into the container below. Here, let's keep going. Now the trick here is you don't want to blow too fast or too strong. You don't want to blow the cup off the top. You just gently want to force that air through the crack. And now the top cup is completely empty. The bottom cup, of course, is full of water, and the top cup is completely empty. It just has air in it. And all the water you can see has gone into the surrounding container, which is why we did that and had that container there to begin with. The question is, how does this happen, right? It's actually quite interesting. What's going on here is you fill the two cups up with water. You stack them on top of each other. When they're perfectly aligned, everything is nice and solid. The water is trying to get out. It's pushing on the seam between the two cups, but you have air pressure pushing back. And those two things are balanced. The cup is sitting there, the water is sitting there, everything's balanced, okay? Now we slightly move the top cup ajar, and we notice that still the water is contained inside the cup, even though there's a clear exit path. And again, that's all due to the invisible air pressure around us. You see, the Earth has an atmosphere many miles thick, and even though we don't think air has very much weight to it, it actually does. So from the point of this cup all the way up to the edge of our atmosphere is a lot of air. And that air is sitting right on top of you, and it's pushing on this cup. Now we can't feel the pressure on our skin because we have internal pressure inside of our body that balances that air pressure. The same that we have the internal water pressure pushing against and balancing against the outside air pressure here. So what we need to do is disrupt that balance somehow in order to get the water to come out of the top cup. And we use a straw. All we're doing is we gently force some air through that interface there. And what's happening is the air coming out of the straw is pushing and it's forcing its way inside of the cup. So it's kind of overcoming that air pressure, the natural air pressure, and it's forcing its way between the two cups. What's happening is the air goes in, and as soon as the air goes into the cup, that then forces and flushes out an equivalent amount of water out of the cup, and it gurgles down the other side. So for every breath you blow in, an equivalent amount of water gurgles out of the other side. And if you do that long enough, then what you're doing is evacuating the top cup without actually touching it with your hands, which is sort of the neat thing about this experiment. Now we want to do the exact same thing again. This time we're going to use clear cups so that we can kind of see a little bit more clearly what's going on. And the experiment actually works a little better with the plastic cups, but you can see a whole heck of a lot more so with the clear cups. So what we're going to do is move these guys over here. Be careful if you're using glass. Now everything is balanced. Again, the water is contained in because of the air pressure pushing. So we'll create a very small gap, just like that. Now we lose a little bit, and so everything, we have a little interface here that's a gap. The water is contained in the same way as before. As we blow in, what's happening is the bubbles are going in. And with each breath, the bubbles going in pushes water out. Until the glass is completely empty. And that is how this experiment works. You have internal air pressure, internal water pressure trying to make its way out, outside air pressure pushing to keep the water inside. When you force air in, the water must come out, and that is showing you how you can overcome that air pressure to evacuate a glass of water that's balanced on top of another glass. Very simple experiment. Go get the materials, do it yourself, and I think you'll find that it's kind of interesting and neat to be able to do.